Hello everyone, I welcome you all to my online classes. Today we shall discuss about algebraic expressions. The very first exercise of the chapter. अपने एक्सरसाइज की तरफ बढ़ने से पहले बच्चों के साथ एक दो बातें। क्लास में हर तरह के बच्चे मिलते हैं। कुछ बच्चे पढ़ाई लिखाई में बहुत आगे होते हैं, बहुत तेज़ दिमाग के बच्चे होते हैं, हर काम को पूरे टाइम से करते हैं। कुछ बच्चे खेलों की तरफ उनका रुझान बहुत ज़्यादा होता है। कुछ बच्चे ऐसे होते हैं जिनका दिमाग कंप्यूटर से भी तेज चलता है। उन बच्चों में से कोई एक बच्चा जिसका दिमाग कंप्यूटर से भी तेज चलता है, टीचर ने क्लास में कुछ कबीर के दोहे उसको एक दिन पढ़ाए। घर में जाकर बच्चे ने कलयुग के दोहे कुछ इस तरह से उसने रचना की। कहते, ऊंचे कुल का छोकरा करनी ऊंच ना होए, ऊंचे कुल का छोकरा करनी ऊंच ना होए, परीक्षा में नकल करे फिर भी पास ना होए। बड़ा हुआ तो क्या हुआ जैसे बिजली का खंभा, बड़ा हुआ तो क्या हुआ जैसे बिजली का खंभा, पूरा दिन बिजली गुल रहे फिर भी बिल है लंबा। ऐसी बाणी बोलिए सबसे झगड़ा होए, ऐसी बाणी बोलिए सबसे झगड़ा होए, उससे झगड़ा ना करो जो हमसे तगड़ा होए। फिर कहता है, कल पढ़े सो आज पढ़, कल पढ़े सो आज पढ़, आज पढ़े सो अब, कल फीस बढ़ गई तो पढ़ेगा कब। मतलब फीस के डर से पढ़ाई करो, वैसे पढ़ने की कोई ज़रूरत नहीं है। तो इस तरह से बच्चे की अपनी सोच या, और मैंने आपके सामने ये दोहे इसलिए रखे हैं ताकि मनोरंजन हो। पढ़ाई के साथ साथ हमारा दिल पढ़ाई के साथ जुड़ना चाहिए। आज हम अपनी पढ़ाई को आगे बढ़ाएंगे। अलजेब्राइक एक्सप्रेशंस आज हमारा नया टॉपिक जिसे हम पढ़ने जा रहे हैं, एक्सरसाइज 12.1। इसमें हम क्वेश्चंस को डिस्कस करेंगे। एक्सरसाइज को हम दो पार्ट्स में डिवाइड कर रहे हैं। फर्स्ट एक्सरसाइज में हम इंट्रोडक्शन, अलजेब्राइक एक्सप्रेशंस होता क्या है इसके बारे में पढ़ेंगे। कोफिशिएंट्स को देखेंगे, कांस्टेंट टर्म्स क्या होती हैं, कांस्टेंट्स क्या होते हैं। मतलब कहने का इसका इंट्रोडक्टरी पार्ट और 50% ऑफ द एक्सरसाइज 12.1। तो आइए बढ़ते हैं आज के वीडियो के साथ। Algebraic expressions, exercise 12.1, class 7. First of all, the introduction. The basic of algebraic expressions, the terms like this, expressions like this, x plus 3, 2x plus 1, 5x minus 3, 2x, etc. These expressions, they are called algebraic expressions. Now question is how the expressions are formed. How are expressions formed? This is the question. In expressions we find two components. One is variable and second is constant. One more term we use in expressions, that is called coefficient. Right? Now, from these examples, first of all we take first example, x plus 3. In this expression, x is the variable. The first term, this is x. x is the variable and 3 is constant. This is the first example, right? Now second example, we have 2x plus 1. In this example, variable is again x, constant is 1, and this multiplier with x, this number is called coefficient. So this, in second part, this is 2, coefficient is 2. In third example also we have the same. Third example, 5x minus 3. In this example, variable is x, constant is minus 3, and this multiplier with x is called coefficient. So coefficient is 5. Now question is, what is the coefficient in first part? Is this 0? No, this is not 0. So if we discuss about the coefficient, then the coefficient of x is 1. This is very important. Now here, fourth example, only 2, only 2x. Now what about the variable? Of course, variable is x. What is constant? Here there is no constant, so we cannot write 1. No constant means 0. Constant is 0. Okay. So what is the coefficient? Coefficient mean what is multiplied with variable. This is 2. Right. So from these examples, this way we can differentiate, we can search what are the variables, what are constants, and what are coefficients. Now we shall discuss about the terms of an expression. Terms of an expression. We shall again understand this with examples. Example 1. Consider the expression 4x plus 5. So here we have two terms. This is first term. This is second term. First term is 4x. Second term is 5. Now we take the second example. Consider the expression in second example 4x square minus 3xy plus 6. So here this 4x square is the first term, minus 3xy is the second term, plus 6 is the third term. So in this expression we have three terms. In first example we have two terms. Now we have third example. Consider the expression only 2x. Now what you can say about the terms? How many terms are here? Of course, there is only one term. Only one term. What is that? That is equal to 2x. Okay. So how we can say, what we can say about the terms? Plus or minus signs, they make the terms. 4x plus 5. Because of this plus sign, in this expression we have two terms. If there are two signs, one is minus, this is plus. So because of these signs, we have three terms. Two signs plus or minus, then it means we have three terms. Like, right? Now next. Now we shall discuss about the factors of a term. Suppose we have the expression 4x raised to power 2 minus 3xy. So first of all, terms. What are the terms? First term is 4x square. Second term is minus 3xy. So now factors. Factors of the terms. The very first factor is 4 into 1x into 1x. 4 into x is equal to 4x square. In second term, the very first, because of this symbol minus 1, or we can say minus 3 is the first factor. Second factor is x. Third factor is y. So minus 3 into x into y is equal to minus 3xy. So this way we can find the factors of a term. Now we shall learn about monomials, binomials, trinomials and polynomials with the help of the examples, with the help of the algebraic expressions. First of all, what about monomials? An expression with only one term is called monomial. Okay, for example, 2x is the expression. Here only we have only one term, so this is monomial. Comma, we take another example. Suppose 1 upon 2. Again, this is only one term, so this is also one example of monomial. Comma, we take third example. Suppose I am writing here 7 upon 2 x. So this is also only one term, single term. So this is the example of a monomial. If I write here minus 9 upon 5 y, this is also a single term. So this is also the example of a monomial. Now what about binomials? An expression which contains only two unlike terms is called binomial. For example, we have 2x plus 1. Here we have two terms. Second example we take here 7 upon 2x minus 5. Here we have again two terms, two unlike terms. Next, suppose I am writing here minus 9 upon 5 y plus 7 upon 2 x. Here again we have two terms, so this is also called binomial. Okay. Similarly, we can also define trinomials. Definition is an expression which contains three unlike terms is called trinomial. Now what is the example? Suppose I am writing here 2x plus 3x square plus 1, 2, 3 terms. Combination of 3 terms. This expression is one example of trinomial. Suppose I am writing second example. Suppose this is 7 upon 2x plus 3x square plus y. 1, 2, 3. We have 3 terms. So combination of 3 terms in the expression, the 3 terms should be unlike. So this expression is the example of trinomial. Lastly, we have the polynomials. Polynomials contains more than three unlike terms. The expression which contains more than three unlike terms is called polynomial. Right? Now here from these definitions we have the word unlike. Let us see what is the difference, what are like terms and what are unlike terms. First of all, like terms. Like terms, if we have first example 2x, 3x, 1 upon 2x, minus 5 upon 2x, 100x, all these terms they are like terms. Why they are like terms? Because variable is same, x, x, no matter what is coefficient. Okay, we don't see the coefficient, just only we see variable. If variable is same, then terms are called like terms. Now what are unlike terms? If I write here 2x, second time I write here 3y, next time I write 1 upon 2z, next time I write minus 5 upon 2u, or here I write 100w. Variables they all are different, so these terms are unlike terms. Now what to do with the like terms and unlike terms? In like terms we can add them. Suppose I am writing 2x plus 3x plus 1 upon 2x minus 5 upon 2x plus 100x. So what we can do here, we can write this way: 2 plus 3 plus 1 by 2 minus 5 by 2 plus 100, and we write the variable outside the bracket. 2 plus 3, 5. 1 by 2 minus 5 by 2 is equal to minus 4 by 2 is equal to minus 2. So this was 5. 5 minus 2, 3. 3 plus 100, 103. So this becomes 103x. So what is the meaning of like terms? We can add the like terms. But in case of unlike terms, if we have 2x plus 3y plus 1 upon 2z minus 5 upon 2u plus 100w, then we cannot add them. We shall stop here. Okay, there is no further calculation. We stop after writing this line. Right? Now we shall solve the questions of the exercise. The very first question is, get the algebraic expressions in the following cases. The very first part is subtraction of z from y. So we write this as from y minus z. This is the answer. Next part is, question is second part, 1/2 of the sum of the numbers x and y. First of all, sum of the numbers x and y, we write this way: x plus y. Thereafter, of 1/2 of this mean divide 2. 1 upon 2. 1/2 mean divide 2. Now next part, the number z multiplied by itself. We write this equal to z into z. Z into z mean z square. Right? Next is fourth part, 1/4 of the product of the numbers P and Q. First of all, we discuss product of the numbers P and Q. So this is called P into Q. PQ mean P into Q. Product of P and Q is written as PQ. 1/4, as this was 1/2. 1/2 mean divide 2. 1/4 mean divide 4. Next part number 5. Numbers x and y both squared and added. So first of all, we square these numbers. So we have the square of x is x square, square of y is y square, and added plus. So this was part number 5. Now next question is sixth part, number 5 added to 3 times the product of the numbers m and n. So first of all, product of the numbers m and n, this is m into n. 3 times mean we multiply with 3. Next is number 5 added. Now we plus 5. This is the answer to this question. Next part number 7 is product of the numbers y and z subtracted from 10. From 10 minus, what we have to minus? Product of the numbers y and z. Product of y and z is y into z. So from 10, yz is subtracted. So this is the answer to this question. Next part, sum of numbers a and b, this is equal to a plus b. Subtracted, this sum is subtracted from their product. Their product mean product of a and b, which is equal to ab. So answer is ab minus a plus b. We can also write this way, ab, if we open the bracket, then this is minus a minus b. Right? Now we come to next question, question number 2. Question number 2, first part, identify the terms and their factors in the following expressions. Show the terms and factors by tree diagrams. The very first part, in part number A, we have the expression x minus 3. So in T diagram, first of all the terms, first term is x and next term is minus 3. Factors already there, they are written in the factors. Now second part, in second part the expression is 1 plus x square. First of all, we have 3 terms. First term is 1, second term is x, and third term is x square. Now their factors, 1, this is already in factors simplest form, x is already in factors, x square, further we can write this as x into x. So this is the tree diagram of the expression 1 plus x square. Now next part, in C part, the expression is y minus y raised to power 3. So first of all, we have 2 terms. First term is y, second term is minus y raised to power 3. Now factors y, this is already in simplest form, no further factor, but in y cube first factor is minus 1, coefficient of y cube, second factor is y, next factor is again y, next factor is again y, because minus 1 into y into y into y is equal to minus y raised to power 3. Now d part, this is 5x into y square plus 7x square into y. So this is the binomial, mean we have two terms. The very first term is 5x into y square and second term is 7x square y. Now next factors of the first term. First factor is 5, second factor is x, next factor is y, last factor is again y. 5 into x into y into y becomes 5xy square. Here in the second term, first factor is 7, second factor is x, third factor is again x because x square we have, last factor is y. So if we multiply 7 into x into x into y, answer is 7x square y. Last part, question is minus ab plus 2b square minus 3a square. So this is the algebraic expression. We are going to make the terms. First term is minus ab, second term is 2b square, third term is minus 3a square. Now next factors. The very first factor of first term is minus 1, second factor is a, third factor is b. Here in second term, first factor is 2, second factor is b, third factor is also b. In third term, first factor is minus 3, second factor is a, third factor is also a. This was the answer to the first part of question number 2. Identify the terms and their factors in the following expressions. Show the terms and factors by tree diagrams. So these are the tree diagrams. Now next question, next part of question number 2. In part number 2, identify terms and factors in the expressions given below. First expression is minus 4x plus 5. So first of all, terms, they are minus 4x and 5. And factors of minus 4x, they are minus 4 comma x. 5 itself is the smallest term, so this is the final answer. We can also write the answer in this table. First part, expression is minus 4x plus 5. So terms, first term is minus 4x and second term is 5. Now factors, minus 4x, this is the first term, its factors are minus 4 comma x, second term is 5. So its factors only 5. Now we take the second part, B part, minus 4x plus 5y. First of all, the terms, first term is minus 4x, comma, second term is 5y. Now factors, first term 4x, its factors are minus 4, comma x. Second term is 5y, its factors are 5, comma y. Now we take the C part. This is 5y plus 3y square. First of all terms, first term is 5y, comma, second term is 3y square. Now factors, first term is 5y, its factors are 5, comma, y. Second term is 3y square, its factors are 3, comma, y, comma, y. Now next part, the expression is xy plus 2x square y square. So the very first term is xy, comma, second term is 2x square y square. Now factors, first term is xy, its factors are x, comma, y. Second term is 2x square y square, its factors are 2, comma, x, comma, x, comma, y, comma, y. Now next part, pq plus q. Here again we have two terms. First term is pq, comma, second term is q. Now factors, pq, first term, its factors are, first factor is p, second factor is q, second term is q, its factors are only q. Next, f part, the expression is 1.2 ab minus 2.4 b minus 3.6 a. So terms, first term is equal to 1.2 ab, second term is equal to minus 2.4b, third term is equal to minus 3.6a. So factors of first term, they are 1.2, comma, a, comma, b. In second term, factors are minus 2.4, comma, b. In third term, factors are minus 3.6, comma, a. So this is the answer to the question number 2, part number 2. Now next, the statement part number 3, identify the numerical coefficients of terms other than constants in the following expression. The very first part is, this is our question number 3. The very first part, 5 minus 3t square. So here in this term, other than constant term, 5 is the constant term. So minus 3 is the numerical coefficient. Right? Now next part, we can also add here numerical coefficient of t square. Okay, now in second part, we write here, first of all, 1 is the coefficient of t. Again, with t square, 1 is the coefficient of t square. Again, 1 is the coefficient of t cube. So we write 1 coefficient of t cube. Now next part, the expression is x plus 2xy plus 3y. Here again we write with x there is nothing is multiplied, mean 1 is multiplied. So 1 is the coefficient of x. Now in second term 2xy, in with xy 2 is the numerical coefficient. Next term is 3y. So we write 3 equal to coefficient of y. Now in part number 4, 100m plus 1000n. Here 100 is the coefficient of m. So we write 100 equal to coefficient of m. Second term is 1000n. So 1000 is the coefficient of n. So we write 1000 equal to coefficient of n. Now next part. The expression is minus p square q square plus 7pq. Here first term is minus p square q square. Coefficient is minus 1. So we write minus 1 is equal to coefficient of p square q square. Next term is 7pq. So 7 is coefficient of pq. 7 is coefficient of pq. Next part, the expression is 1.2a plus 0.8b. Here 1.2 is the coefficient of a and 0.8 is the coefficient of b in second term. Next part is 3.14 r square. So we write here 3.14 is equal to coefficient of r square. Now next question, next part. This is 2 into L plus B. First of all, we write this expression as 2 into L plus 2 into B. So again we write from here 2 is the coefficient of L and 2 is the coefficient of B. Next part, the expression is 0.1y plus 0.01y square. So here the very first term is 0.1y, second term is 0.01y square. Now what about the coefficients? We write 0.1 is equal to